We'll be considering another question on separation of variable, that is solving partial differential equation using separation of variable. Solve Uxx minus Uy is equal to 0 by separation of variable. So in this form, what is our Ux? Our first step is what? We assume that, let's assume that U of x comma y is xy, where s is x of x and y is equal to y of x, y of small letter y. So it means our Uxx is a second order. This is a second order partial differential equation. So Uxx is the square u all over the x square. Then Uy, that is a function with respect to what? U with respect to y. So it means the u all over what? The y. I can easily replace this and this in form of this, or I can solve it in form either way. So let us use this. The square u all over the x square minus u of y, that is uy is what? The square u all over what? The y. Then is equal to 0. So I will now assume that what? Assume that u is equal to x comma y. That is, whenever I see u, I put xy. So here I'm going to have the square u. What's my u? Xy all over what? Over the x square, or partial square xy, minus the, what's my u? Xy all over what? The y is equal to 0. So what am I going to do next? I'm going to do is what? I will have to what? I'm going to differentiate this one twice with respect to what? X. So it means I will differentiate it. It's a second order, that is 2 times. If I differentiate this, if I have the u all over what? If I have u of x comma y, that is u of x, I'm having x and y. So the u all over the x here, what am I going to have? The u all over the x here is what? I'm differentiating with respect to y only. I'm going to have y. If I have y, so it means since I'm using partial differential equation, I'm going to have what? The what? I'm going to have the x all over the x. Remember, I've explained this before. If I differentiate again, it means I'm going to have the square u all over what? The x square, which will give me what? Y the square x all over the x square. Because I'm not differentiating this, I'm differentiating this one again. I'm going to have what? The square x all over what? The x square. So this, the square root over the x square. So this will not be what? Form of this. So what of here? I'm differentiating with respect to y. Here I'm going to have, if I have u as what? U as what? Xy. And I'm differentiating with respect to what? The u over what? The y. Differentiating y only. Because since y is a what? Y is equal to y of x of small letter y. So I'm going to have what? I'm going to have x the, with respect of that value, the y all over what? The small letter y. So it means I will now plug in this in this. I will now plug in this in this. So what am I going to have? So there's square root. So I'm going to have y the square s all over what? The s square minus what? This gave me what? S the y all over what? This one letter y. Then it's equal to what? 0. So what am I going to have next? So I'm going to what? I'm going to solve this. My next is what? To divide by what? Divide through by what? Xy. Divide through by xy. If I divide through by xy, what am I going to have? I'm going to have y the square s all over what? The s square minus s dy all over dy is equal to 0. If I divide by s square, it means I'm going to have all over s xy is sy all over what? Xy. So here all over what? Xy. So what am I going to have here? I'm going to have 1 over what? This xy, it means it will be what? Y d square x all over what dx square times 1 over xy, and minus s dy all over what dy times what 1 over xy is equal to 0. So why we cancel this, I'm going to have 1 all over what s d square s all over what dx square minus what s will cancel. I'm going to have what minus 1 all over y left dy all over dy, then it's equal to what 0. So you can see that this is a what is a second order, that is, this is a second order partial differential equation. So I cannot integrate this. I will just make this one as a what? I will equate this as what? As a constant k. So I'm going to have 1 all over x d square x all over dx square. Then I will take this one to here is equal to what? 1 all over y dy all over dy. I will now equate. I will equate both sides. Equate x and y as a particular constant k. As a particular constant k. If I equate this one as a particular constant k, what am I going to have? I'm going to have d square x all over what? dx square is equal to what? Is equal to k. Then I'm going to have y as what? 1 over y, or that is 1 over y dy all over what? Dy as what? As is equal to k. So I can make this one to be equation 1, equation 2. So let me solve from equation 1. So since I cannot integrate this, next step is to integrate, but this one is a second order. I cannot integrate second order. I will have to what? I will assume that the square s all over what? The s square is equal to k. That is, let's assume. Remember that I have 1 over x here. I'm going to have 1 over x. That is x 1 all over x 1 all over x. That is the square s all over what? S ds. So from this, I'm going to have 1 over s the square s all over what? The s square is equal to k. Yes, that I will assume that what? I will multiply s to both sides. That is, multiply s to both sides. So I'm going to have x multiplied by 1 over x, the square s all over what? The s square, then k multiplied by x. S will cancel this. I'm going to have the square s all over what? The s square is equal to what? Ks. So from here, I will make this one to be an homogeneous equation. That is, if my what? G of s is equal to 0, I'm going to have the square s all over what? The s square minus ks is equal to 0. So from here, I can now assume that, let's assume y is equal to, let's assume s is equal to exponential ms. If I differentiate this s prime, I'm going to have m square exponential ms. If I differentiate again s prime, I'm going to have, if I differentiate again m square exponential ms. So it means if I have s prime, it means it is second order. So whenever I see the squares, or I can say s prime is what? M square exponential. I'll just plug in this. So I'm going to have m square exponential ms. That is, the square s all over the s square is also known as what? S double prime minus k. So what's my s? Exponential ms is equal to 0. So for me, I will divide both sides by exponential s, exponential mx, then exponential ms. So I'm going to have, this will cancel. I'm going to have m squared minus k is equal to 0. So I'm going to have m squared minus k. So I'm going to solve this. I cannot, this is k, this is 0. I'm going to apply my quadratic formula. So my a here is 1. My b here I don't have. Then my c is what? K. That is m squared. My c is what? K. As a constant. So I'm going to have m is equal to minus b plus minus b squared minus 4ac all over 2a. So what is my minus b? Is 0. So I'm going to have 0 plus or minus square root of b square. What is my square root of b square? B is what? 0 minus what? 0 minus 4 times 1 times c. Then all over what? All over 2. 2 times 1, 1. So I'm going to have m as what? Plus or minus 0 plus or minus 0 plus or minus. So minus 4k. Minus 4 times k. So I'm going to have minus 2i. That is square root of minus 4. That is square root of minus 2k. That is minus square root of what? Root minus 4k. So my m will now be, since it's 0 plus or minus 2i, then root k. I'm going to have root k. So my m is equal to 0 plus 2i, because I'm having what? Our k here is what? Minus. That is c is what? Minus k. So minus k. So it is 4k. That is 2 root 4k. So I'm going to have 0 plus minus 2 root k. So for me, my m is equal to what? 2 root k, or my m is equal to what? Minus what? 2 root k. So my x will now be a exponential mx plus b exponential mx. Since they are not the same thing, so my m is what? A exponential 2 root kx plus b exponential minus 2 root kx. So for me, my x is this. I've gotten my x. So next is what? To get my y. This is my y already. Equation 2. So I'm going to have from equation 2, I'm going to have 1 over y dy all over dy is equal to k. So here I'm going to have, if I cross multiply, I'm going to have dy all over y, then k dy. If I now integrate, I'm going to have 1 all over y dy, then k dy. So if I integrate 1 over y, I'm going to have ln y. Ln y is equal to, if I integrate a constant with respect to y, constant integral k dy, I'm going to have ky plus c. So I want to get value for y. I'm going to take exponential on both sides. If I take exponential on both sides, I'm going to have this plus exponential c. This will cancel. I'm going to have y is equal to what? C1 exponential ky. So since our u is equal to what? Since u is equal to s of y, x and y. So what is my x? X is what? A exponential 2 root ks plus b exponential minus 2 root ks. Multiplied by what? Kx multiplied by what? C1 exponential ky. So my general solution will now be a exponential 2 root kx plus b exponential minus 2 root kx multiplied by what? Multiplied by what? C1 exponential what? Ky is the general solution to the PDE. So this is the solution to the PDE. It means I've used separation of variable to solve the partial differential equation. It means I did not use 2. 2 times a is what? 2. So all over 2. Here is all over 2. So it means 2 divided by 2, I'm going to have 1. So it is 1 plus or minus 1 root k. So my m is root k or minus 1 or minus root k. So it means it's minus, not 2. So a exponential root kx plus b exponential root kx minus root kx. Then my answer is, so this root is affecting only k. So it means my general solution for this is a exponential root kx plus b exponential minus root kx multiplied by what? C exponential ky. So this is the solution to the PDE given.